Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. We are given an array of elements. In that array, all the elements appears even number of times except the two elements that appear odd number of time, and our task is to find those two elements. So let's see with example. Here we have array of elements 1 1 2 3 4 4. In this array 1 appears 2 times, it means even times, and 4 appears 2 times, it means even number of times. But 2 and 3 appears odd number of time. So the output of this input is 2 and 3. Let's see next example. In this example, array is having 5, 5, 6, 7, 8, 8 elements. And here 5 appears even numbers of time, 8 also appears even number of times. But 6 and 7 appears only one time, it means odd number of time. So the output of this input is 6 and 7. So here I would like to tell you one thing, that in this problem, there are always going to be 2 odd occurring numbers. It's never going to happen that you get 3 occurring number or 1 odd occurring number. It's guaranteed that you will get always 2 odd occurring numbers. We have seen variation of this problem in previous video. In that problem, we had to find one occurring number in a given array. This problem is just an extension of the previous problem. And in this problem, we have to find 2 odd occurring number in a given array. So if you have not watched that video, then I highly recommend to watch previous video first and come back here and continue watching this video, because we are going to use some concepts discussed in previous video to solve this problem. So let's pause this video, watch the previous video, and think about an algorithm to solve this problem. So let's quickly see brute force approach to solve this problem. So the idea of brute force approach is simple. We are going to pick one number at a time, and we traverse the entire array from first element to last element, and we count occurrence of each element. Whenever count becomes odd, we simply print that number, right? So let's see the implementation of this idea. Here is the implementation of brute force approach. Here we have a function, and this function is taking an array as input. In first line, we are running a loop from 0 to array.length. Inside of loop, we are initializing count to 0. Then again, we are running a loop from 0 to array.length. In inner loop, we are checking if array of I is equal to array of j. It means in first loop, we are picking one number, and in second loop, we are checking entire array for that number. And if we found that number, we simply increment the count by 1. And after loop gets completed, if the value of count is even or odd. If the value of count is odd, we simply print that number. So let's quickly try run this code and see how it works. So in case of this array, we have elements 1, 1, 2, 3, 4, 4. So in first iteration, the value of I is 0 and 0th element is 1. So we begin the inner loop and we simply count the occurrence of number 1. We get count as 2, and 2 is not an odd number, so we simply skip this step. We do not print anything. In second iteration, we do the same thing. In third iteration, when I becomes 2, the second element of this array is 2. Now this time when we count the occurrence of 2, we get 1, and 1 is odd number, so we simply print 2 on the screen. And we follow the same steps for other elements also. So in this array, we are going to get 2 and 3 as output. Okay, clear. So let's talk about the time complexity of this function or this algorithm. So our outer loop runs n times. It is clearly, you can see clearly that we are running a loop from 0 to array.length. It means it runs n times. And for each iteration of outer loop, the inner loop also runs n times. So the total time is going to be n into n, because it is a nested loop. That's why we are multiplying n into n. Okay. So the overall time complexity of this algorithm comes out to be theta of n square. And it belongs to quadratic order of growth class. Okay, clear. So the time complexity of brute force approach is n square, and that is a quadratic order of growth. So can we do it better? Do we have any other approach to solve this problem? Can we solve this problem in less time? Or I would say, can we solve this problem in linear time? Yes, we do have solution to solve this problem. And with that solution, we are going to solve this problem in linear time. And in that solution, we are going to use XOR operator. So again, let's pause this video and think about an algorithm to solve this problem. Now let's discuss the idea for efficient solution. So let's say we are given an array with all these elements inside of array. 1, 1, 10, 13, 4 and 4. So in this array, 1 appears even number of time, 4 appears even number of time, and only 10 and 13 are the numbers that appear odd numbers of time. So the output should be 10 and 13. So let's see step 1 of this efficient solution. So step 1 is same as previous problem. Again, if you have not watched the previous video, I highly recommend to watch the previous video first and then come back here and continue watching this video. So what we do in first step, we simply do XOR of all the elements. So elements are 1, 1, 10, 13, 4 and 4. So we do XOR of all the elements. So by using the inverse property of XOR, the 1 and 1 cancel out each other, 4 and 4 cancel out each other, and we end up with 10 and 13. And if we do XOR of 10 and 13, we get 7. Okay? Because the binary representation of 10 is this, binary representation of 13 is this. So when we do XOR of 10 and 13, we get 7. Okay? So this is the first step. Now, we have observations to be made. In 7, you can see clearly that 3 bits are set. First, second and third. And we know that whenever XOR operator gives us 1, it means there are 2 alternating bits. And by doing XOR of those 2 bits, we get 1. Right? It means in all the 3 places, there should be 2 alternating bits in all the 3 places. It means there are 2 alternating bits in all the 3 places. That's why we got 1, 1 and 1. Clear? So far so clear? Now the challenge is we have to use the binary representation of 7 and figure out 2 odd occurring number. In this case, that is 10 and 13. So let's see how to find 2 numbers using the binary representation of number 7. So as we see that the first bit of 7 is set. It means there are 2 numbers where the first bit of any one number is 0 and the first bit of any other number is 1. So we know that. Okay. So what we do in this? We divide the entire array into 2 groups where we find all the numbers whose first bit is set, and then we do XOR of all those numbers, right? So in this example, the numbers whose first bit is set is 1, 1 and 13. So when we do XOR of 1, 1 and 13, we get 13, and this is our first number, right? Similarly, we collect all the numbers in this array whose first bit is unset. So what are all the numbers? 10, 4 and 4. And when we do XOR of 10, 4 and 4, we get 10. So this is how we are going to use the binary representation of 7 and find out 2 numbers that appears odd number of time. By using the fact that if the bit is 1, it means there are 2 numbers where the first bit of first number is 0 and the first bit of second number is 1. Remember this fact, okay? Now how to check if the bit is set or not? And we have already discussed this problem in previous videos, that how to check if kth bit is set or not. Okay, so what we do, we simply do bitwise AND with a number whose kth bit is set. If we get number greater than 0, it means the kth bit is set. For example, let's say the binary representation of 3 is 0011 and I want to check if the second bit is set or not. So what I do, I simply do bitwise AND with a number whose this bit is set, only this bit. So I get a number, and if this number is greater than 0, it means the bit is set. Okay, so this is what we do to check if kth bit is set or not. But in our case, the challenge is very different. Now here the challenge is, now here in this problem we got 7, but it might be possible that if you have any other problem, you would have got 6 as the XOR of all the numbers, or you would have got 4 as the XOR of all the numbers. So here you do not know which bit you need to check. right? It may be possible that you have to check first bit or second bit or third bit. We do not know anything. So basically we need a number whose only rightmost bit, it means LSB, is set. Okay, so in case of 7, the binary is 0 1 1 1. So we need a number whose only first bit is set and all other bits are unset. And why we need to do this? Because by using this number, we divide our array into two groups. One group has first bit set and second group has one bit unset. That is why we have to do this. Now let's see how we find that number. Now here we are going to take help of Brian Kernighan's algorithm. So again, if you have not watched previous videos of Brian Kernighan's algorithm, I highly recommend to watch that video. Okay, moving on. So let's say we have 7 and 7 has 1, 2 and 3 bits are set. So if I want to unset this last significant bit, then what we do in Brian Kernighan's algorithm, we simply do bitwise AND with one number less than this number. It means we do bitwise AND with 6. But in this case, we do not want to unset this bit. Rather, we want to set this bit and we have to unset all other bit. So in this case, what we do? We simply invert all the bits in 6. Here we are using NOT operator. So using NOT operator, we simply invert all the bits. So 0 becomes 1, 1 becomes 0, 1 becomes 0 and 0 becomes 1s. And 0 becomes 1. Now if we AND 7 with NOT 6, we get a number whose first bit is set and all other bits are unset. So finally we got our number, and using this number we can divide the array into two groups. Now, okay, clear. So this solution is going to work with other numbers also. Let's say you would have got 6 as the XOR of all the numbers, and in 6, second and third bit is set. So if we do bitwise AND with NOT 5, you get a number whose second bit is set and all other bits are unset. So this technique is going to work in all the cases. So now we got our number. So now we got the number. We are almost done. Now what we have to do now? We just have to divide array into two groups to get two odd occurring number. So let's see how we do it. So let's see the efficient implementation of the approach discussed above. So here we have a function odd occurring number, and this function is taking array as input. In first line, we are initializing our x to 0 and we are running a loop from 0 to array.length, and we are calculating XOR of all the elements, and this is our first step. In next step, we are simply finding a number whose least significant bit is set. Okay. After finding that number, we are initializing two variable a and b to 0. Now again we are running a loop from 0 to array.length, and in this array we are dividing our array into two groups. So in if loop we are checking if the kth bit is set or not. And how we are checking? We are simply doing bitwise AND with element and k, and if the bit is set, we are doing XOR with a, and if the bit is not set, we are doing XOR with b. So this way we collect all the elements in variable a whose kth bit is set, and we are collecting all the elements in b whose kth bit is not set, and at the end we print both the elements. So let's see how it works. In case of this array, in step 1 we get 7. Why? Because we XOR all the elements in first step, and the binary representation of 7 is 0 1 1 1. In second step, we do x and not x minus 1, so we get number 1. And binary representation of number 1 is 0 0 1 0 0 0 1. Okay. In step 3, we are simply dividing our array into two groups. So in A, we are doing XOR of 1, 1 and 13, and in B, we are doing XOR of 10, 4 and 4. So after doing XOR of 1, 1 and 13, 13 gets stored in variable A and 10 gets stored in variable B. So we get output as 10 and 13. So these are the two numbers that appear odd number of time in a given array. Great. So talking about the time complexity of this function, how many times our loop is running? So we can see that our first loop is running n times, and similarly second loop is also running n times. So the total time is going to be n plus n, that is equal to 2n. And in asymptotic analysis, we simply ignore constant and lower order term. So we simply cancel out 2. We are left with only n. So the overall time complexity of this algorithm comes out to be theta of n. And this is a linear order of growth. And this is much better than quadratic order of growth. Alright, so let's have a quick recap of what we have learned so far. So we are given a problem. In that problem, we are given an array of elements, and in that array, all elements appears even numbers of time except 2 elements that appears odd numbers of time, and we have to find those 2 numbers. So we saw brute force approach to solve that problem, and the time complexity of brute force approach came out to be theta of n square. Then we saw the efficient approach using XOR operator to solve this problem, and time complexity of this efficient approach came out to be theta of n. So I hope now you have a clear understanding of how to find 2 odd occurring element in an array. So this is it for this video. Thanks for watching. See you in the next video.